good day to you wonderful people. So here is the lesson for today. We're going to continue with the scientific toolkit. This is what you need to do physics and chemistry for the most part. All right, but before I move on, make sure you check out the quiz. In every video that I upload, there's a quiz attached to it, either description below or in the actual pinned comment. All right, let's move on. A few rules we have to follow for significant figures rules and the uncertainty. Okay, first of all, the concept of significant figures and uncertainty is based on the experimental concept. That means that we are just as accurate and as precise as the instrument that we use, and we can't make it up. Okay, and there are certain rules that we have to follow. I have actually made a list of the set of rules, and then we're going to get into the operational part, because there are two rules with the operation with significant figures as well. All right, the first one, non-zero digits always significant. So 3, 4, 5, these are all non-zero digits. How many significant figures do we have? We have 3. Very good. 0 between non-zeros always significant. So here we go, 3007. There are 4 sig figs. Okay, so that's what that is. Leading zeros, never significant. So leading zero, look what's happening here, 0.0045. None of these zeros are significant. So only 45, 4 and 5, there are 2 significant figures, and that's it. Trailing zeros, decimal present. So this is trailing zero. There's a decimal here, and if it is, that is significant. And now you count them: 1, 2, 3, 4, 5. That's 5 sig fig. Very nice. Trailing zeros, non-decimal. This is the part that most students make a mistake. That is not significant. Those zeros are not significant. So in here, 1500, there's only 2 sig fig because of 1 and 5. That's it. The 2 zeros don't count. And then exact numbers, infinite sig figs. So for example, if you get 12 students, we don't know if it's 12.0 or if it's 12.00, and so forth and so on. We say that's infinite sig figs. We can't really, it's an ambiguous case. We can't really know exactly. One more thing with the scientific notation, I did not add that here, but I should. And that is, if you have a setup like 2.3 times 10 to the power of 2, when you have a setup like that in the scientific notation, the power of 10 does not count. Anything before the multiplication counts. So here you just follow the same rules. So in this case, we have 2 sig fig. So 10 to the 2 or 10 to the negative 2 or 10 to the 15, and none of that counts. Only the digits and the placeholder. That's all it is. So the 2.3 counts, or however many sig figs we have based on the rules that we talked about. Now, operation rules with examples. Now, this operation rules applies to the sig figs, and that is super important for chemistry and physics. All right. So when you're dealing with operation, there are 2 different operations we have to work through. One is multiplication and division. The other one is addition and subtraction. There are 2 different rules we have to follow. Kind of the same actually, but here is the explanation and an example we're going to go through. The final answer has the same number of sig figs as the factor with the fewest sig figs. So what does that mean? So let's look at this example. 4.56 times 1.4. Which of the 2 numbers got a lesser number of sig figs? Well, it is 1.4. So when you do the multiplication using a calculator, at the very end, once you're done, you need to round your answer either up or down based on what you have to 2 sig fig, and this is what the answer is, 6.4, and that's 2 sig figs. Okay, so remember, you have to round it at the end. Don't do it intermediately. All right, the next one is addition and subtraction. This one, the final answer rounded to the least precise decimal place. Now, this is the part that I need you to pay attention. So let's walk through this. 12.11 plus 3.2. Now, when you look at this, the 12.11 is more accurate than 3.2. The 2, that decimal place, is the least precise measurement, because we don't know if this is 3.20 or is it 3.21 or is it 3.22. Our instrument is just giving us as accurate as it can be, but is the least accurate, which is that one decimal place, which is that rounded to tenths, right? So when we add the two numbers, now when you add them, what will you get? You will get 15.31, right? But because our least precise decimal place is the tenth, we need to round this to the 10th place, and that would be 15.3. And that is the rule for addition and subtraction. Now let's look at one more question. We want to do the calculation for this expression. 7.3 gram plus 5.57 gram divided by 1.254 centimeters cubed. Okay, that's actually a density setup here. So with the situation like this, you have to use BEDMAS. That means you have to deal with the top first, okay? And the rules of Sig Fig and also the rules of the addition subtraction for Sig Fig applies here. So here it is. We have the tenth is the least precise measurement. First, we're going to add them. So this will end up being 12.87 gram divided by 1.254 centimeters cubed. But then once we have this, now we have to round it up to the tenth, because the 10th decimal, that placeholder 10th is the least precise. Therefore, the 12.87, we have to change that to 12.9. We're going to round it up and then divide it by 1.254. That's the gram, that's the centimeters cubed. Now that we have used the addition or subtraction rule for Sig Fig, we're going to use the division and multiplication. We're just going to go ahead and divide. And then once we divide, we're going to use the least number of Sig Figs, which is 12.9, which is 3. So our final answer will have 3 Sig Figs, okay? So 3 Sig Figs, our last answer. And the answer is, so when you divide, you get 10.287 approximately. And of course, we're going to change that to 3 Sig Figs. So that would be 10.3 gram per centimeters cubed. That's your final answer, and with the proper number of Sig Figs. All right, so I hope this was useful. This was the second example. I went through this Sig Figs, and then certainly again, I'm going to link the first video that I did about the significant figures and uncertainty as well. I've done that a few months ago. Actually, I think about last year I did that. So I'm going to link that to in the description below. Make sure you go over both of them just to get more practice. All right, and don't forget to take the quiz once you're ready, either as a review or as testing your mastery. All right, until next time.